but the third shell can hold 18. Alright, so we put the 10 here for the D, so that we have 2, 6, and 10 adds up to 18. Okay? And the fourth shell, or let me write that a little bit further down because I'm running out of room. Fourth shell has a S, P, D, and F subshell. Okay, we know S holds 2, P holds 6, D holds 10, F holds 14. Right, so we add that up and that's 34. Is it 34? 18, yeah, 34. So, this is how we understand the shells of an atom. So if we're looking at this, picture this, the nucleus of an atom, and these are the energy levels or shells. Okay, this is the first shell, so we're only going to have 2 shells, 2 electrons on this shell situated here, and that shell is full. It can no longer hold electrons. The second shell can hold 8, so it's going to have 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth throughout the entire shell. The third one can hold 18, so you would have 18 little electrons here, and on the last you would have 34. Okay, so given this knowledge, we know that we can account for every electron in an atom of any given element. Now, let me move this over a bit. Now, given our sodium atom right here, what we're going to do now is we're going to write out the electron configuration of this atom. Okay, we know it has 11 electrons. Alright, 11 electrons, as you can see, for sodium right there. Now, going back, like I said, we can write out exactly where each electron is, and we do that by drawing a little number chart. So we would go in the first shell, which only has an S. We have 2 electrons for remember, Na has 11 total, so we have to keep filling this up until we reach 11. So in the first shell, 2 electrons are there, so we've taken away 2 from the total of 11, which would give us 9. Alright, so we still have 9 electrons to place. So the second shell can hold a S and a P, like I've said before. So we consume 2 of those electrons in this shell, the 2s shell, which would bring us down to 7 electrons. The P can hold 6. Alright, so we've placed 6 more of those 7 electrons in the P subshell. So that would leave us with only 1 electron left to place. So we would go to the 3s subshell and just place 1. Even though it can hold 2, we have no more electrons to be able to place, so therefore you just have to put a S1. And this is the electron configuration of sodium. If we go to another one, for example, let's use, I don't know, potassium, which is signaled by K on the periodic table and has 19 electrons. Okay. So K, or potassium, has 19 electrons. Alright? And we would do the electron configuration by writing this out here. We'd say 1s, 2 electrons, 2s, 2, 2p, 6. I forgot to write 2 here. Always write the shell and the subshell that you're putting. Always write the number of the shell next to the subshell that you're filling. Okay? 3s2. So now we've gotten 2, 4, 10, and 12. So we've taken away 12, which leaves us with 7 electrons. Alright? And so we go to the next 3 shell, 3p, and that would consume 6. So we would have only 1 electron now to place. And now see what happens with when after you fill the 3p subshell, you always have to go, I know it's going to sound weird and this is going to be confusing, but you always have to go directly, you have to skip the D subshell and go directly to the 4s and then go along fitting the the 3D subshell. So in this case we would go to 4s2 or 4s1 because we would only have 1 more electron to place. And that would fill all of the 19 electrons. We have 2, 4, 10, 12, 18, 19. Okay? And that's how we identify exactly in which subshell and shell every electron in any given atom of, or in any given atom of an element is. And you know, I know it sounds confusing at first, but if you guys want, try and I don't know, fill the subshells for calcium or titanium as a form of homework. All right, and any questions, please direct them towards my email account, and I'll be happy to help you out. Like I said, it's not an easy thing to learn, and I don't profess to be the greatest teacher in the world, but you know, I think it's an important thing that people should know. So until next time, I'm signing out. Good night. God bless.